Okay, so now we have problem number 4, and this one is probably the hardest out of all of them. First, if you notice, all of these are basically fractions. So if we find out where the denominator equals 0, we know that the function won't exist at those points, so we'll have what are called asymptotes. If we plug in a positive 2 here for x minus 2, that would make that 2 minus 2, which would make this 0 squared in the denominator, which ultimately means that we're going to have a asymptote at x equals 2. So we're just going to notate that here, that this is 2, and there's going to be an asymptote, meaning that the function is not able to exist there. So next we find where this equation would equal 0. So the only way this could equal 0 now is if, because this bottom part can't equal 0, then the numerator would have to equal 0, and that would happen, we can do x plus 4 equals 0. That would happen when x equals negative 4. So on this number line, we'll have negative 4. And so to see whether this will be positive, we can test out x values that are either less than negative 4 or greater than negative 4. The other thing we can do is find out where our y-intercept is by plugging 0 into both of these terms. So let's do that first. So at d of 0, we'll have 0 plus 4, and we'll have 0 minus 2 squared. And so the reason we do this is just so that we get a better picture of what this graph will look like. So this will be 4 over, this will be negative 2, but then we're squaring it, so that'll be positive 4. So this will equal 1. So we know that at x equals 0, y will be 1. And we can annotate that as 0, 1. We know that negative 4 here, the graph equals 0. So we'll put that point here, or the y values equal 0. So let's test out the left side of 4. This is where the x values are less than negative 4, so we can do that by taking, let's say, d of negative 5. So on the top here, this will give us negative 5 plus 4. On the bottom, this will give us negative 5 minus 2 squared, and that will be negative 1 over, and this will be negative 7 squared. So this is going to be a negative number, negative 1 over 49, which basically means that all the values on this side of the graph are going to be negative. So we can do something like that, showing that the graph, when x is less than negative 4, are all negative. And then we can solve for x value between negative 4 and x equals 2. So again, we're testing a value between negative 4 and 2. Even we know that it hits 1, 0, or sorry, it hits y equals 1 when x equals 0. So let's just try d of 1. Nice and easy. So this will give us 1 plus 4 over 1 minus 2 squared. And that's going to give us 5 over the negative 1 squared. And so this is going to be positive, so we're going to get a positive 5. And that's somewhere all the way up here. So the rest of this graph, or at least the graph from negative 4 to 2, is going to look something like this. It's going to go infinitely up to infinity, but it's never actually going to be, or there will never be a y value at x equals 2. And then on this left side, we know that this function has to continue. So again, this function will go up, but never actually have a y at x equals 2. And it'll come back down this way. Okay, then we have e of x equals 2x plus 8 over x minus 1. So first let's find out what the y value is at x equals 0. So e of 0 will have 2 times 0 plus 8, and then we'll have 0 minus 1. And this will give us 10 over negative 1, which gives us negative 10. So at x equals 0, we're going to have y equals negative 10. And we can annotate that as 0, negative 10. Okay, so next we see that the denominator here is x minus 1, which means that at x equals 1, this will be 0 in the denominator, which would make the function undefined, which means we'll have a asymptote there at x equals 1. So again, we can do a little dotted line here, and we'll say that this is 1. And then now let's find where the y values will equal 0. So the only place that the function will equal 0 is where the numerator equals 0. So we'll do 2x plus 8 equals 0. And when we solve this out, we get x equals negative 8 over 2, which equals negative 4. So at x equals negative 4, y will be 0. So we'll have a dot here, and we'll annotate that as negative 4, 0. And we can use our number line here to have negative 4. So now we got to test a value, an x value that's less than 4 and greater than 4. So let's do e of negative 5. So e of negative 5 will give us 2 times negative 5 plus 8 over negative 5 minus 1, which gives us negative 10 plus 8 over negative 6. And so this will give us negative 2 over negative 6, which is positive 1/3. So we know that all the y values less than negative 4, all of these y values are going to be positive. And then we'll test all the x values greater than negative 4 up until x equals 1. Okay, so let's test out e of negative 3, since that is between negative 4 and positive 1. So we'll have 2 times negative 3 plus 8 over negative 3 minus 1. And that will give us negative 6 plus 8 over negative 4, which will give us positive 2 over negative 4, which will give us a negative 1/2. And so that is going to be negative. And remember that it has to go through this point down here, which is 0, negative 10. And so it'll go down like that, never actually having a y value at x equals 1. And then this graph continues again on this side, and it will look like this. If you need to, if you don't know what it's going to look like on this side, then just plug in some values, at x equals 2, and then at x equals 3, 4, 5, so on. But it's going to look more or less like this. Okay, so the last function here, I'm going to actually leave this up to you guys to solve. It looks very complicated, but I'll get you started. So the first step here is to actually FOIL out this equation here, and I'll just give that to you. That will be 2x plus 1 times 2x plus 1 over x minus 2 times x plus 2. So just follow the same steps that I did up here. Find f of 0 so that you can find your y-intercept. You see here that if you get a negative 2 or a positive 2, then you're going to get asymptotes. So at negative 2 and positive 2, you're going to have asymptotes. Next, you set this whole thing up equal to 0, and you have two terms here, so that's actually easy. So you just set 2x plus 1 equal to 0, so that you can find out where this graph will equal 0. And then once you have that, you can test out the graph at negative or positive, and just remember that the graph continues on this side of the asymptote as well. Alright, so that does it for this video. There's a lot to cover, so just keep practicing. You're going to have to put at least an hour extra of whatever you're doing now to really get what Precalc is saying. So if you did find this video helpful, please give it a like and subscribe, and I'll see you in the next one.